Hello everyone. Today I'm going to present a topic from the field of data mining called sequential pattern mining. In today's digital world, a huge amount of data is generated every second from online shopping, social media, streaming platforms, and many more sources. But raw data alone is not useful unless we can extract something meaningful onto it. Sequential pattern mining is one such technique that helps us identify patterns where the orders of events is important. In this presentation, I will explain the concept clearly, discuss all applications, walk through the working process, and finally demonstrate it using an example. So, let me start something small that we daily experience. When you open Netflix, you see recommendations that match your taste almost perfectly. Similarly, when you shop at Amazon, it suggests products that you are likely buy next. So, have you ever wondered that how these systems are so accurate? The answer is they don't just look at what you did, but also order in which you did. For examples, for many users, uh, if many users watch a particular movie and then watch another one, the system learn this pattern. This is exactly what sequential pattern mining does. It identifies such sequences, uses them to predict future actions. So this is how the Netflix and Amazon know what you will do next. They predict the next recommendation after you watch your favorite movie. They'll predict their next recommendation movie. So sequential pattern mining is a data mining technique used to discover frequent sequences of event in a data set. The key idea here is that sequence or the order matters. For example, uh, consider two sequences here, A to B and B to C, and C to B, B to A. Even though they contain the same elements, they represent completely different patterns. So in this technique, we are not just finding frequent items, but we are finding frequent ordered patterns. This makes it very useful in analyzing time-based data, user behavior, and event sequences. So this is the definition of sequential pattern mining and a key idea of what it means exactly. So let's understand this by a simple and relatable real life example. So suppose if a customer visits an online store on day one, so they buy a phone. After a few days, they purchase earphones. Later, they buy a phone cover. So the sequence becomes phone phone to earphones to cover. So if the pattern is observed across many customers, the system can predict that the person who buys a phone is likely to buy a earphones next. This helps businesses provide better recommendations, improves user experience, and increase sales. So this is one of the real life example of sequential pattern mining. So basically, it becomes a predictable pattern that retailers can act on. So coming to the next slide, sequential pattern mining has a wide range of applications. In e-commerce, it helps in product recommendation systems, uh, predict next purchases and optimize product recommendation engines based on browsing sequences. And in streaming platforms like Netflix and YouTube, it suggests content based on viewing history. It recommends the next show or song by analyzing the watch order across the millions of users. And in web using, web usage mining, it analyzes how users navigate through websites. So, and it understands clickstream behavior to improve site navigation and reduce user drop off. In healthcare, it identifies disease product. It can identify patterns in symptoms or treatments over time. It identifies progression patterns and sequence to support clinical decisions. And it's also used in financial analysis to decide the fraud patterns. So overall, it plays a crucial role in decision making and excuse me, decision making and predictive analysis. Uh, Coming to the next slide. Now let's understand how pattern mining works step by step. First, we collect sequential data. So this could be user actions, transactions, or any time-ordered events. Next, we define a threshold called minimum support. This determines how frequently a significance must appear to be considered significant. Then we scan the dataset to identify all the sequences that satisfy this minimum support. Finally, we generate frequent patterns that follows a specific order. These patterns are then used for analysis and prediction. So here is the whole diagram of how it works. So the process starts with the raw transaction or behavioral logs, applies a minimum support threshold or filter surfaces only the sequences that occur frequently enough to be meaningful. So this is how the frequential data mining works. So coming to the next slide. To understand this better, let's look at the simple data set. Excuse me. We have three sequences here. A to B, B to C, and the second sequence is A to C, and the third sequence is A to B. Each sequence represents a series of events or actions. Our goal is to analyze the data set and identify which sequences are frequent based on the minimum support value. This example will help us understand the working of an algorithm clearly. So this example mainly shows that which sequence have the basic minimum support value that will you should identify that sequence and support count is nothing but number of sequences given containing in a given pattern. So for this the minimum support is 2. That means the pattern must appear greater than or equal to in two sequences and then it is considered valid. Coming to the next slide. To extract patterns, we use an algorithm called a priori based sequential pattern mining algorithms. So this algorithm works on simple principle. That is, if a sequence is frequent, then all of its subsequences must also be frequent. So this is the simple principle that a priori based sequential pattern mining algorithm works on. So first we identify the frequent individual items. So then we combine them to form longer sequences. After that we eliminate sequences that do not meet the minimum support. This process is repeated until no more valid sequences can be generated. It's an efficient way to discover patterns step by step. So in this slide we saw that we use an extra algorithm called a priori based sequential pattern mining algorithm. So this algorithm is iterative and self-pruning. Find frequent one item sequences, extend to longer sequences, combine frequent items into candidate sequences, prune and repeat. The third step is prune and repeat. It's nothing but remove weak candidates and iterate until no new patterns emerge. So these are the three steps in which the a priori based algorithm. So step one is nothing but find frequent one items. Step two is nothing but extend sequences, and step three is pruning and repetition. Coming to the next slide. Now let's execute the algorithm on our data set. First, we count the frequency of individual items. So here A appears three times, B appears two times, and C appears three times given in the question. So since all of them meets the minimum support and they all are considered frequent. Next, we check the sequences. A to B appears two times, A to C appears two times, and B to C appears here only one time. So since B to C appears, B to C does not meet the minimum support, we eliminate it. So the final frequent patterns are A to B and A to C. So these patterns represent the meaningful relationships in the data. So here in the given question, the minimum support is given as 2 and three items are given A, B and C, and so we eliminate the item based on the minimum support the item has provided. So this is one algorithm based on our data set, and B2C appears only in S1, so it falls below minimum support and is discarded. So as the minimum support is 2 and the B2C minimum support is 1, so it reduces, it is lower than the minimum support provided in the question, so it is disregarded and it's not and it's not used in the case. And coming to the conclusion of our presentation, to conclude, sequential pattern mining is a powerful and important technique in data mining. It helps us understand patterns in ordered data and enables system to predict future behavior. It is widely used in recommendation systems, business analytics, healthcare, and many other fields. Although it requires large data sets and it can be computationally intensive, the insights it provides are extremely valuable. So, in short, it transforms raw data into meaningful patterns that help in better decision making. So, for revision, let me revise the advantages and limitations of the of this sequential pattern mining. So, the advantages, excuse me. So the advantages are enables accurate next action prediction, powers personalized recommendation systems, reveals hidden behavioral insights. And the limitations are computationally expensive on large data sets, requires carefully tuning of support threshold, and they may generate many redundant patterns. So the core principle of this sequential pattern mining is that in sequential data, order is information. Ignoring it may cause may mistake the pattern entirely. So this is the core principle of in the sequential pattern mining. So these are the advantages and limitations, and and thank you for your attention. And I would be happy to answer any questions if you have. So this is the presentation on sequential pattern mining. Thank you.